In this video, I want to have a closer look at rhombuses, rectangles, and squares. So we can see from our quadrilateral family tree that rectangles and rhombuses are both special types of parallelograms, and that a square has all the properties of both a rectangle and a rhombus. We're also really quickly just going to have a look at kites. So if we have a look at rhombuses first, a rhombus is a parallelogram that has a pair of adjacent sides equal. So two sides that are next to each other, like this one and this one. What that means is because opposite sides of a parallelogram are equal, that means that all four sides of our rhombus are equal in length. So the properties of a rhombus, it has all the same properties of a parallelogram, but it also has that all four sides are equal. It has not just that the diagonals bisect each other, but that they bisect each other at right angles. So they'll meet and those diagonals will be perpendicular. And also that the diagonals bisect the angles at each vertex. So that means where this diagonal comes into this corner, this angle here is equal to this angle. And that will happen in each of the four vertices. So if we're given a quadrilateral and we want to prove that it is a rhombus, there's three ways that we can do that. We can prove that all sides are equal. We can prove that the diagonals bisect each other at right angles, or we can prove that the diagonals bisect each vertex. Next, we have rectangles. So the definition of a rectangle is that it's a parallelogram with one right angle. So if we have one right angle in a parallelogram, we know that opposite angles are equal. So that means that this one over here would be 90 degrees as well. And we also know that adjacent angles are supplementary. So if this one's 90, then this one down here would be 90 as well. So the definition that it has one right angle, that actually means that all four angles are going to be right angles. So the properties of a rectangle, again, it has all the same properties of a parallelogram, but it also has that all four angles are right angles, and it has that our diagonals are equal. So if we went from one corner to the other, that length would be equal to if we drew the other diagonal in. For us to prove that a given quadrilateral is a rectangle, then we can do one of two things. We can either prove that all four angles are equal, or we can prove that the diagonals are equal and that they bisect each other. So it has to be equal and bisect, not just one or the other. When we're talking about squares, I've just pulled up our family tree again. A square is a rectangle with adjacent sides equal. So you could actually define a square as being both a rhombus and a rectangle. So that means that a square has all the same properties as a rhombus and a rectangle. So we've got quite a big list of properties of squares now. And if we wanted to prove that a shape was a square, we would have to prove that it was a rectangle and prove that it was a rhombus. So if it's both of those shapes, that means it is a square. So the last type of quadrilateral that you might come across would be a kite. And that's this guy over here. He doesn't fit into trapezium or parallelogram or any of the others, but he is a quadrilateral. So a kite is a quadrilateral that has two pairs of adjacent sides equal. So that means that this side here is the same length as this one, and these sides here are the same length as well. All right, so that's the rest of our quadrilaterals and their properties.